A very good morning, good afternoon, and good evening to all. So, today we will discuss the question number 1 to question number 16 that is released by Cbse in his official website. So, first question is a uniform electric field pointing in positive x direction exists in a region. So, let us draw the uniform electric field represented by parallel straight field lines. So this is our uniform electric field E vector, and as per the question, let A be the origin. So let A is a point, take it as origin, and B is the point on the x-axis at x equal to plus 1 centimeter. So at x equal to plus 1, B is another point, and also it is given C be the point on y-axis at y is equal to plus 1 centimeter. That means the location of C point is, as per the question, this one. So then the potential at point A, B and C satisfied as. So we know equipotential surfaces are perpendicular to electric field. So this dotted line represents our equipotential surface. Okay, so as this line represents equipotential surface, so potential at A is equals to potential at C, and also we know that electric potential decreases along the direction of electric field. So also electric potential decreases along electric field, so which implies potential at B is less than potential at A. So if we will compare these two equations, we can write VC is equal to potential at A is greater than potential at B. So as per the options given, VA is greater than VB. This is our answer. Option B is the correct answer. Next, second question is a conducting wire connects two charged conducting spheres such that they attain equilibrium with respect to each other. Suppose these are two conducting spheres and they are connected with each other by conducting wire, and let the radius of the first conducting sphere is R1 and radius of the second conducting sphere is R2. So as per the question, they attain equilibrium with each other, equilibrium with respect to each other. So in this case, what is the meaning of equilibrium? As they attain equilibrium with respect to each other, it means potential of first sphere is equal to potential of second sphere. So thus we can write, and after that question is given the distance of separation between the two spheres is very large as compared to either of their radii. That means due to this given statement, if you will observe the second sphere from the first sphere, it behaves as a point object because that separation is made too large. So potential due to point charge, we can write V is equal to KQ by R. So for V1 we can write KQ1 by R1, and for V2 it will be KQ2 by R2. So it is equal to Q1 by Q2 is equal to R1 by R2. And as per the question, find the ratio of magnitude of the electric fields at the surface of two spheres. That means we have to calculate E1 by E2. Okay, so what is the electric field intensity due to first sphere? It will be KQ by R square. That means KQ1 by R1 square divided by KQ2 by R2 square. So it will be q1 by r1 square into r2 square by q2, and we have q1 by q2 is equals to r1 by r2. So r1 by r2 into r2 square by r1 square. So final answer is r2 by r1. So in this question, option B is the correct answer. Next, question number 3 is, a long straight wire of circular cross section of radius A carries a steady current I. The current is uniformly distributed across its cross section, and the ratio of magnitude of magnetic field at a point A by 2 above the surface of the wire to that of a point A by 2 below its surface. Okay, so before solving this question, we have to know about the theoretical part based upon this concept. So what is that? So now see, this is our solid conducting wire, and this is the axis of the wire. Okay, and the current through it, let it be Y. So through its cross section, I amount of current is flowing as per the given data. Okay, so as per the given data, I amount of current is flowing, and let the radius of this sphere is small a. Small a is the radius of this sphere, radius of this cylindrical wire. Now consider a point which is present outside of the sphere. So let P is a point which is present outside of the sphere, and the distance of point P from the axis of this solid conducting wire, let it be R. So how to calculate the magnetic field at point P? That is our question. So in order to calculate the magnetic field, we have to think about an Amperian loop. So this is that Amperian loop as per Ampere's second law. So if we will apply Ampere's second law to calculate the magnetic field at P, okay, the expression is closed integral B vector dot dl vector is equals to mu naught into I inside. Okay, so if we will solve, it will be B dl cos 0, that is mu naught. What is the amount of current available inside the Amperian loop? You have to check. So inside this Amperian loop, the total current I is flowing. That means we can write I. Then cos 0 value is 1. Take B is constant, let outside. Then this closed integral dl, it is equal to mu naught into I. And the closed integral dl is called your perimeter of Amperian loop. It is the perimeter of Amperian loop, and the radius of this Amperian loop is smaller, so the value will be B into 2 pi small r is equal to mu naught into I. So B is equals to mu naught I by 2 pi small r. So this is the value of magnetic field at a point present outside of this conducting cylindrical wire. Okay, and what is R in this case? R is the distance of this point of observation from the axis. We have to remember this thing. So this is the formula to calculate the B outside. Okay, in case of if the point is present inside the cylindrical wire, that means let's think, let Q is another point. Q is a point which is at a distance smaller from this axis. In order to calculate the magnetic field at Q, we have to think about Amperian loop. Yes, this red color circle is our Amperian loop. So as per the Ampere's second law, again we can use this formula, closed integral B vector dot dl vector is equals to mu naught into I inside. That means again it will be B mu naught. And what is the value of I inside? I inside means amount of current inside this Amperian loop. And if you will observe it properly, then you see through the area pi a square, through this area pi a square, the total current I is flowing. Okay, that means this is our area and this is current. So in area pi a square, amount of current available is I. So through unit area, amount of current is I by pi a square. And the area of this Amperian loop, that is our pi r square. So through pi r square area, amount of current will be I by pi a square into pi r square. If you will solve, it will be I r square by a square. Okay, so this is the value of I inside. So instead of I inside, we can write I r square by a square. Again, what is this integral closed integral dl? This is the perimeter of Amperian loop. So we can write B into, this will be 2 pi small r is equal to mu naught I r square by a square. So solving, we get B is equals to mu naught I r divided by 2 pi a square. Yes, so this is B inside. And here also you have to remember what is r. R is this distance of point of observation from the axis of this solid cylindrical wire. And what is A? A is this radius of this solid cylindrical wire. So as per this question number 3, a long solid wire of circular cross section of radius A. That means you have to draw the diagram. So this is the solid cylindrical wire and this is the axis. This is your radius A as per the given question. So carries a current I. Yes. The current, the ratio of magnitudes of magnetic field at a point A by 2 above the surface of wire. That means one point is there. Let this point is P is a point which is at a distance A by 2 above the surface of wire. Okay. And another point is that A by 2 below its surface. Another point is Q, suppose. It is at a distance A by 2 below its surface. Yes. So question is, you have to find the ratio. That means B at P divided by B at Q is required. So how to solve? P is outside point. So we can write B at P is equal to, that formula is mu naught I. See this formula, mu naught I by 2 pi r. So mu naught I by 2 pi small r. So what is small r? Distance of this point of observation from this axis. So if you will think about this distance, it will be A plus A by 2. So here small r is equals to A plus A by 2. That is 3A by 2. So put it. So mu naught I by 2 pi into 3A by 2. So solving, we get mu naught I by 3 pi A. This is the B at P. Now B at Q. So Q is inside point, and for inside point the formula is mu naught I r by 2 pi a square. So we can write mu naught I r by 2 pi a square. So what is r in this case? Again you have to calculate the value of r. R is the distance of the point Q from the axis. So it will be r. So it will be A minus A by 2. That is A by 2. So instead of r, we can write mu naught I A by 2 into 2 pi a square. So solving, we get mu naught I by 4 pi a. So according to question, B at P divided by B at Q. So it will be mu naught I by 3 pi a divided by mu naught I by 4 pi a. So solving, we get our answer is 4 by 3. This is the answer. So option C is our correct answer. Okay. Next question is question number 4. The diffraction effect can be observed in sound wave only, light waves only, ultrasonic waves only, and sound waves as well as light wave. This is a theoretical question. The correct answer is your sound waves as well as light wave. And here you have to remember what is the necessary condition for diffraction. Condition for diffraction. Condition for diffraction is, necessary condition for diffraction is d should be less than or equals to lambda. That means what is d? D is the size of obstacle. And what is lambda? Wavelength of the sound wave or light wave. Wavelength. Yes. Next question number 5 is, a capacitor consists of two parallel plates just like this. These are two parallel plates with an area of cross section 0.001 meter square. So it is given according to question, area of cross section is 10 to the power minus 3 meter square, separated by a distance of 0.0001 meter. That means distance of separation between two plates is 10 to the power minus 4 meter. If the voltage across the plates varies at the rate of 10 to the power 8 volt per second. So all of you observe this unit volt per second. That means the given data is dV by dt is given to us, that is equal to 10 to the power 8 volt per second. Then the value of displacement current through the capacitor is dash, and displacement current ID is required. So how to solve this? So ID, we can use the formula current equal to dq by rate of charge, rate of flow of charge. So dq by dt. So instead of this q, in case of capacitor, the q can be written as d by dt of q formula is Cv. Yes, and capacitance is a constant quantity, take it outside. So C into dV by dt. And this is the capacitance of this parallel plate capacitor given in this question. So capacitance of parallel plate capacitor having plate area A and separation between them is what? D. That formula is A epsilon naught by D. A epsilon naught by D into dV by dt. So now we can use the respective values. Area is given 10 to the power minus 3, D is 10 to the power minus 4. So this is 10 to the power minus 3, epsilon value 8.854 into 10 to the power minus 12 divided by 10 to the power minus 4. dV by dt is given 10 to the power 8. So we can write 8.854 into 10 to the power minus 3 minus 12 plus 4 plus 8. So this is 0. So final answer is 8.854 into 10 to the power minus 3 ampere. All are in SI unit. So first option is our right answer, 8.85 into 10 to the power minus 3 ampere. So this is all about your question number 5. Next, the question number 6 is a very important question. In series LCR circuit, the voltage across the resistance, capacitance and inductance is 10 volt. So let's draw a rough diagram. So we have to connect three things: inductor, capacitor and resistor in series. So inductor having inductance L, capacitance C and resistor having resistance R. So this is inductor and capacitor, another one is resistor. Inductance L, capacitance C, resistance R, they are in series, and it is given voltage across them is 10 volt. That means voltage across inductor is equals to voltage across capacitor equal to voltage across resistor is 10 volt. We know voltage formula, current into resistance. So instead of VL we can write, and that current is your RMS current. We can write it as IRMS into XL is equals to IRMS into XC is equals to IRMS into R. is equal to 10. By solving, we can write XL equals to XC is equals to R is equal to 10. Okay, as per the given data, we can write like this. Okay. Achha. Next thing is they are in series. All these three components are in series and they are connected to a voltage source. This is your voltage source. They are connected to, all these three components are connected to voltage source. This is your voltage source. Okay, so our aim is to calculate what is the source voltage. How to calculate? So in case of a series combination of L, C and R, so total resistance, that is called impedance. So we can calculate the impedance in this case. So impedance formula Z is equals to R square plus XL minus XC whole square root over. So as XL is equals to XC, we can write R square plus 0 square root over, that is equal to R. So this is your impedance value is R. Okay. Now we can calculate the source voltage. So thus source voltage is equals to source voltage, that is equals to how much? We can write I into Z, I RMS into Z. That value is equals to 10 volt. Okay, because Z value is R, so I RMS into R. We can write this is equals to 10 volt. So source voltage is 10 volt. Again, as for the given question, next part is if the capacitance is short circuited, the voltage across the inductance will be dash. Capacitance is short circuited means in next diagram we have to draw the diagram after excluding the capacitor. Okay, you have to omit the capacitor, simply remove the capacitor from the circuit as it is short circuited. So rest thing is your inductor, another one is resistor. Okay, inductor having inductance L, resistance R. Okay, then it is asking what is the voltage across the inductance. So voltage across the inductance will be VL. So as per the value, we can write voltage across inductance is equals to I RMS into XL. Yes. Now tell, when L and R in series, L and R are connected in series, what is the value of I RMS? We know current equal to voltage by resistance. So in this case, L and R are in series. So this will be V RMS divided by what? Impedance Z into XL. So when L and R are in series, the impedance will be V RMS is equals to, V RMS divided by Z is equal to how much? R square plus XL square root over. Okay, this is the value of impedance Z. Finished. Into, next thing is into XL. Into XL. Okay, so now tell, R is equal to XL. We have derived. Yes, R is equal to XL. So we can write V RMS value is 10 divided by R square plus R square root over into, instead of this XL we can also write R. So final answer is 10 by, this will be root 2R into R. Okay, after solving we get the final answer is 10 by root 2. Yes, so this is the voltage across inductance. So 10 by root 2, option C is our right answer. Yes, next is question number 7. So correct match of the column 1 with column 2 is dash. So 4 things are given in case of column 1 and 4 things are given in case of column 2. Okay, so in our syllabus, okay, in our syllabus we have completed so many things: infrared wave, radio waves, light wave, then microwaves in our electromagnetic induction. Okay, so if you will see these 2 column, then here it is written light wave. Another point is given, electrons in atom emit light when they move from higher to lower energy level. Okay, so this statement is in relation with light actually. Yes, so option 3, sorry, in case of column 1, the 3, that is light, is interrelated to Q. The final answer is this one. Option B is our answer. Okay, here 3 is interrelated to S, it is incorrect. 3 is connected to S, it is incorrect. Then 3 is in relation with P, this is also incorrect. So our correct answer is B. Next, come to our question number 8. The distance of closest approach of an alpha particle is d when it moves with speed v towards a nucleus. Okay, so when the velocity, or sorry, speed of alpha particle is v, the distance of closest approach is d as per the given question. And it is asking that another alpha particle is projected with higher energy such that the new distance of the closest approach is d by 2. So what is the speed of projection of alpha particle in this case? So we have to calculate what is new speed of projection, let it be v dash. So our aim is to calculate the v dash value. So come to your theoretical part. This is suppose your nucleus, okay, and the whole figure representing your atom. Okay, now see in this diagram, suppose alpha particle is coming towards the what? Nucleus. Okay, and when alpha particle reach at this point, it will suffer maximum repulsion from the nucleus. Okay, so this the minimum distance between this alpha particle and nucleus. In this case, it is called what? Distance of closest approach, d. So initially alpha particle is having kinetic energy. So when alpha particle, okay, will reach at the final point, then there will be electrostatic potential energy between alpha particle, another one is what? Another one is your nucleus. Yes, so here kinetic energy of alpha particle gets converted to electrostatic potential energy between alpha particle and nucleus. So the formula is kinetic energy is half mv square, and electrostatic potential energy when the separation between these two particle, alpha particle and nucleus, is d. The formula is k q1 q2 divided by d. q1 is the charge of alpha particle, q2 is the charge of nucleus. So if you will observe, we came to know that the v square is proportional to 1 by d. We can write v square proportional to 1 by d. So if v square is proportional to 1 by d, we can use this relation in order to solve this numerical. So in question it is given when speed is v, the distance of closest approach is d. So for what value of v, the distance of closest approach will be d by 2. That we have to calculate. So v square, as per the formula, v square proportional to 1 by d. So we can write v by v dash whole square is equals to d dash by d, as it is inversely proportional. Okay, we know x, when x is proportional to y, so x1 by x2 equal to y1 by y2. So when x is proportional to 1 by y, that means x1 by x2 equal to y2 by y1. Like this we can write when v square proportional to 1 by d, so we can write v by v dash whole square equal to d dash by d. So now put the respective value. So what is d dash? D dash is your d by 2, okay, into d. So after solving we will get 1 by 2. So taking square root on both sides, so v by v dash will be 1 by root 2. So v dash is equals to root 2v. So root 2v is our correct answer. So for question number 8, our option number B is right answer. Okay, I hope it is clear to all of you. Next is question number 9. So there are question up to question number 16 we have to solve. Yes, so question number 9 is a point object is placed at the center of a glass sphere. So suppose this is the glass sphere and this is the center of this glass sphere. Okay, and at the center the point object O is present, and radius of this sphere is 6 centimeter. That means this to this distance is 6 centimeter. It is given according to question, and the refractive index of this glass sphere is 1.5. So refractive index is 1.5. Ng is equal to 1.5. So the distance of virtual image from the surface of the sphere is dash. Okay, so now all of you focus upon this theoretical part. In theory we have discussed, if this is our glass surface, suppose this is our glass surface, okay, this is our glass surface having refractive index n2, okay, and the medium refractive index is n1, which is present around this glass surface, curved glass surface, okay. So this is that glass surface, yes, and let's draw its principal axis in order to form the image. This is the principal axis. Let us consider this is our object O, yes. So from O incident ray is emerging, yes. So this is your center of curvature. At this point of incidence we can draw the normal like this, yes. So after refraction the ray starts to bend and the final image will form at I, yes. So this is the pole. So pole to object, this is your object distance U, and pole to image, this is the image distance V. I am not using the sign convention till now, okay. Only I am representing the object distance and image distance in terms of U and V. So our formula is N2 by V minus N1 by U is equals to N2 minus N1 by R. So what is our radius of curvature? Pole to center of curvature. This is the radius of curvature of this curved glass surface. So this formula we have to use in order to find the image distance. But what you have to remember in this case, what is N2 and what is N1, that what is also important, very very important. So what is N1? All of you remember, N1 is the incoming Ri. Incoming Ri means refractive index of that medium in which incident ray is present, or you may think a refractive index of that medium in which object is present. And N2 is the outgoing Ri. N2 is our outgoing Ri. So now focus upon this question part. So there is a glass sphere of radius 6 cm of refractive index given 1.5, and the distance of virtual image from the surface of the sphere is dash. Same thing we can apply from the object. Incident ray is emerging, this is incident ray, and we are considering this surface, this part of this glass sphere, okay. So refraction will happen. So in this case what we have to do, this is suppose our principal axis, and let this point is our pole, yes. So what is our incoming Ri? Incoming Ri is denoted by N1. So incoming Ri means refractive index of that medium in which incident ray is present. So incident ray is present in glass sphere. So our N1 value is 1.5. What is N2? Outgoing Ri. So after refraction, the refracted will move in air. That means surrounding medium, nothing is given, means it is air. That means refractive index of air is 1. Then next part is what is U. V is required as per the question. What is U and what is R? U is the object distance. How we have to use sign convention, as per sign convention. So object distance is measured from the pole to object. So pole to object, now see, pole to object means it is opposite to incident ray. So U is minus 6 cm. Next is radius of curvature. Radius of curvature also pole to center. So center is at O. So radius of curvature is also minus 6 cm. So now we can use the formula for this question. N2 by V minus N1 by U is equal to N2 minus N1 by R. So now put the respective value. N2 value is 1 by V minus N1 value. N1 value is 1.5 by minus 6 is equals to 1 minus 1.5 divided by radius of curvature minus 6. So it will be 1 by V minus minus plus 1.5 means 3 by 2. So it will be 3 by 2 into 6 is equals to 1 minus 1.5, that is minus 0.5 divided by minus 6. So after solving we get 1 by V plus it will be 1 by 4 is equal to, we can cancel these two minus signs. So 0.5 means 1 by 2. 1 by 2 divided by 6, that is 1 by 12. So 1 by V is equals to 1 by 12 minus 1 by 4. So it will be LCM is 12. So 1 minus 3, that is minus 2 by 12 minus 1 by 6. So 1 by V is equal to minus 1 by 6 means V is equal to minus 6 centimeter. So now check the options. So options are available in magnitude format. So final answer is our 6 centimeter. This is our correct answer for the question number 9. Next is question number 10, that is theoretical question. Colors observed on a CD compact disc is due to diffraction. Okay, this is available in our theoretical part. The number of electrons made available for conduction by dopant atoms depends strongly upon, the correct answer is our doping level in semiconductor. Okay, you all have read. Then question number 12, you see the question number 12 is from chapter electricity. If copper wire is stretched to make its radius decrease by 0.1%, then percentage change in its resistance is approximately dash. Okay, so we have to solve this question in a detailed manner. So percentage changes, that is percentage decrease of radius, is given to us. We know R is equals to rho L by A. So upon stretching, bending, the volume of the wire is constant. Okay, we can apply volume conservation concept. So as radius of percentage change in radius is given, so what we have to do, I can write it as like this, rho into L by A into, I can multiply A on the numerator and also A on denominator. So it will be rho L into A, we can write it as length into area of cross section, that is volume, divided by A square. And instead of this A is the area of cross section. Don't think that it is area. This is area of cross section. So this will be pi r square. So rho V by pi r square whole square. So rho V by pi square r to the power 4. And also you see rho V by pi square, this is a constant. Let this constant is beta. So beta by r to the power 4, or beta into r to the power minus 4. This is the value of, so r is equal to beta by r to the power 4, that is beta into r to the power minus 4. So now we can write d capital R by d small r. So what will be the value? D by d small r of beta into r to the power minus 4. Solving we get beta is constant, take outside, then d derivative of r to the power minus 4, small r to the power minus 4. So the answer is n into minus 4 into x to the power n minus 1, that means r to the power minus 4 minus 1. So final answer minus 4 beta r to the power minus 5, that means minus 4 beta by r to the power 5. So if I will arrange this thing, okay, arrange the whole thing. Now see in what way I am going to arrange. So minus 4 by r into beta by r fourth. Check it. Same as previous. Okay, r into r to the power 4, that is r to the power 5. So now by arranging in such way, we can put instead of beta by r to the power 4, I can write r. R is equal to beta by r to the power 4. Is it clear? So now put minus 4 capital R by small r. So d capital R by d small r is equals to minus 4 capital R by small r. So arrange again. D capital R by capital R is equals to minus 4 by minus 4 into d small r by r. Then we can write d capital R by capital R into 100%, that is equal to minus 4 into d small r by r into 100%. Yes. So what is the meaning of d capital R by r into 100%? This is percentage change in resistance. So our formula is percentage change in resistance is equals to minus 4 into this all total is your percentage change in radius. Minus 4 into percentage change in radius. And all of you remember, we can apply this formula if this percentage change in radius is very small. So use this formula when a very small change, when a very small percentage change of radius is given. Okay, yes. So for this question we can use this formula, because percentage decrease in radius is given 0.1%. So what we have to do? So percentage change in resistance is given. So percentage change in resistance, that is equals to minus 4 into percentage change in radius. It is given percentage decreases by 0.1%. So in order to mention this decrease word, we have to use minus 0.1%. Okay, so the final answer is plus 0.4%. Okay, option C is our right answer in this case. Yes. Next, question number 13. So question number 13 to 16, assertion reason type question. So first question is given, on increasing the current sensitivity of a galvanometer by increasing the number of turns may not necessarily increase its voltage sensitivity. So current sensitivity, voltage sensitivity formula. So current sensitivity IS, that is equal to deflection per unit current, whose formula is BAN by C. Torsional constant is C. And for voltage sensitivity we can write Vs, that is phi by V, deflection per unit voltage, unit applied voltage. So it is your BAN by C into R. So now see in this formula, current sensitivity increases by increasing the number of turns. Now see, number of turns and current sensitivity, they are directly proportional to each other. Yes, it is true. But it is written, it may not necessarily increase its voltage sensitivity, because if we will increase the number of turns, then length also increases, and length increases means the resistance will increase. So on increasing the number of turns, simultaneously resistance will increases. That means the ratio of N by R, that remains same. That means the voltage sensitivity value remains same. Yes, that means as per the question, whatever is written on assertion, that is also correct, 100% correct. And in reason it is written, the resistance of the coil of the galvanometer increases on increasing the number of turns. Yes, it is true, and it is the correct explanation of assertion A. So option A is our answer. Yes, both A and R true, and R is the correct explanation of A. Then question number 14. In a hydrogen atom, there is only one electron, but its emission spectrum shows many lines. Yes, in case of hydrogen atom, suppose you consider there are many hydrogen atom. Hydrogen atom means this is one electron system. Okay, this is one electron system. It is having only one electron, but we don't know in which orbit the electron is revolving. Yes, that is the fact. Okay, if you will consider different hydrogen atom, you can't guess in which orbit the electron is revolving, but we can say that each hydrogen atom consists of one electron. So in a hydrogen atom there is only one electron, but its emission spectrum shows many lines. This is true. Why it is true? Because we can't predict, or we can't tell that all the electrons are revolving in a in a fixed orbit. In a fixed orbit means if in one hydrogen atom electron is revolving in suppose third orbit, we can say in another hydrogen atom that is revolving in the third orbit, we can say it may be fourth orbit, it may be fifth orbit. So due to this, they will show different spectrums. So in region it is written, in a given sample of hydrogen there are many atoms is containing one electron. This is correct, and hence many electrons in different atoms may be different orbits, maybe in different orbits, so many transition from higher to lower orbits are possible. Okay, so when in one hydrogen atom the electron suppose in third orbit, okay, so transition can take place from 3 to 2, 3 to 1, but when it is in fifth orbit, fifth to 1, fourth to 1, sorry, fifth to 1 or fifth to 2, like this. So both A and R are true, and R is the correct explanation of A. So option A is our right answer. A and R are true, and R is the correct explanation of A. Then question number 15. So nuclei having mass number about 60 are least stable. Okay, mass number 60 means it is representing about which nuclei? Middle nuclei, and middle nuclei are stable. Okay, so it is mentioned nuclei having mass number about 60 are least stable. Okay, this is wrong. And reason it is written, when two or more light nuclei are combined into a heavier nucleus, then the binding energy per nucleon will decrease. Okay, now see, we have read binding energy per nucleon, the binding energy for mass number versus mass number. So what is the nature of this graph? The graph is something like this one. Yes, like this. So this representing our middle nuclei. This is your middle nuclei, and this is for lighter nuclei, and this is for heavier nuclei. So it is written, when two or more lighter nuclei combined into a heavier nucleus, that means they combine to form, or when two or more lighter nuclei will combine, then they will achieve what? The structure of middle nuclei. That means the binding energy per nucleon increases. When two or more lighter nuclei will combine, binding energy per nucleon will increase, but it is written it will decrease. So this is wrong. So both A and R are false. So as per the option, if both assertion and reason are false, so option D is given. Yes. So question number 15, the answer is option D. Yes. Next is our last question. De Broglie's wavelength of a freely falling body keeps decreasing with time. We know the de Broglie wavelength is lambda is equal to h by p. P is our momentum, linear momentum. So h by m into v. So for a freely falling body, you remember the velocity continuously increasing. Yes, because it is an accelerated motion. So velocity is increasing. So if velocity increases, that means lambda will decrease. Yes. So it is written de Broglie wavelength of a freely falling body keeps decreasing with time. Yes, this is true. And in reason it is written the momentum of the freely falling body increases with time. Obviously, momentum of freely falling body increases with time. Okay, mass is a constant quantity, but velocity increases continuously. So as a result, the product m into v, that means the linear momentum, that increases with time. So the reason is also correct. And as the product of m and v, that is linear momentum, is increasing, that means lambda decreases with respect to time. So both A and R are true, and R is the correct explanation of A also. So option A is our correct answer. Okay, so this is all about for today's class. Thank you. Have a nice day.